Hello everyone. So welcome back to day 4 of AI Agents workshop brought to you by K.A.M.A.L.A. And today we will be covering the topic memory in agents and LLMs. Right. So before we actually start with like what exactly memory is, right? So let's understand the word itself. So memory basically means that if you are talking to someone, or if you are, let's just understand it this way, if you are conversating with someone, right, and let's just say if I say hi, my name is Rajat, and the other person says hi, my name is Prachit, and assume that one of us forgets the other's name in just 5 seconds, right? So that is not an ideal example of memory, right? Because the entire context gets switched, and like you don't remember the crucial and the essential kind of information of that particular conversation, right? So same way, if we don't like take or provision steps to introduce memory to our AI agents, or when we are conversating with LLMs, the entire conversation goes out of context. So kind of take it this way. In human conversations, we naturally remember past interactions to make sense of the current movement. AI agents are no different. For them to hold meaningful and coherent conversations over time, they need memory. In LangChain, memory helps the model recall previous exchanges and use that context to respond appropriately. Imagine talking to someone who forgets everything you said a moment ago or maybe 5 minutes ago. It may be frustrating, right? So that is what AI agents are like without memory. Memory helps agents retain the flow of a conversation and understand what was said before, which is especially important for building chatbots, personal assistants, or tutors. It enhances user experience by making the interactions feel more natural, responsive, and consistent. So there are basically two types of memory on a technical scale, but the entire concept is just this. If you are conversating with an LLM or an AI agent, the entire conversation should be kept in a context, right? It should not forget what you said a moment ago. So for this, I will show you a very practical example. So what I will do is I will open like a fresh page of chat GPT on an incognito window where none of my accounts are logged in, right? So it cannot you can say fetch my user details, and it does not have any conversations which I had on my accounts with chat GPT. So it's like a fresh new session. So what if I ask what is my email? So it will not be able to tell me my email because there is no memory architecture introduced in this particular session. It has no access to my information, and it has no like there are no previous conversations of me and chat GPT. So there is no way it can get my email. But what if I feed my email into it? My email is rajat@gmail.com. So once my email is fed into it, right, it will kind of just say that for privacy and security, it does not store my personal information, right? But what if now I ask what exactly my email is? So what is my email, since now you know about it, right? So this is kind of an example of in-session memory, although it is not storing it anywhere. It is just fetching our previous conversations and replying as per that. But that's why memory is important. You can assume that you have an AI agent that is running 24/7, right? So on day one, you entered a certain data into it, but on day two, that AI agent forgot what data, like what and which type of data was entered into its system on day one. So that would be a hassle, because then you would need to kind of recreate or reset that particular AI agent. So that's why memory is necessary. So now if I refresh the page and if I ask what is my email, it will forget it because the chat got changed, the chat got resetted, and the entire context just switched and switched to an entire new session. So that is a kind of an example why do we actually need memory in LLMs and AI agents. So coming back to our presentation, so there are two types of memories which we will be discussing today with the help of LangChain a bit more technically and practically. So the first type is buffer memory, and the second type is summary memory. So buffer memory is, as per the theoretical definition, buffer memory is a concept where your entire conversation with an AI agent or an LLM is stored word to word, like everything is stored, and it may eventually scale up the database where the information is getting stored. But yes, but in summary memory, a word to word information is not stored. Rather, a summary of all the, the summary of the entire conversation is stored into one place, and then the AI agent can refer to it, or the LLM can refer to it, and bring you the summary, or respond to you properly. So let's just read the bookish definitions for the same. Buffer memory is the most straightforward type. It simply stores all the past messages in order. This means every input and output is recorded as is. It's ideal for short conversations where you want the AI to remember everything exactly. However, over time this memory can grow large, which can impact performance due to token limits in the underlying language model. Summary memory takes a smarter approach. Instead of storing the entire dialogue, it summarizes the key points using the LLM itself. And like as the conversation continues, the summary is updated, capturing the essence while keeping token usage low. This makes it suitable for long running conversations where we want the model to remember the important bits without exceeding context limits. So we understood how buffer and summary memory works, right? Now we will be exploring it practically, and the prerequisites of this practical today's practical session is Python, and we will be providing you with an open AI API and the LangChain modules of Python, which I believe that you must have installed if you have followed this AI agent bootcamp or workshop so far, because the last session of ours was on LangChain, right? But even if you have not, don't worry, we will kind of summarize it along the way. And yes, let's fire up our Visual Studio Code or any IDE which you use, and let's get started with the practical implementation. All right, so after a quick water break, I am back, and now let's move forward with the practical implementation of buffer memory and summary memory, right? So here are a few commands which you need to kind of use in any folder where you will be working. So firstly, create a folder, open Visual Studio Code in it, right? And I mean, just use these commands. So I will also explain you. So the first command does is that it creates a Python virtual environment. What second command does is that it opens and activates that particular virtual environment, right? And like once that particular virtual environment is activated, we will be installing the necessary Python modules. So I already have my virtual environment configured, right? So I will simply open a new terminal. I will zoom it out a little, right? So, okay. So then I will just simply copy paste this command. So once copy pasted, since I have already globally installed these modules, for the people who will be installing it for the first time, it may take more than 30 seconds for you people to kind of get it configured on your device. But if you have followed this bootcamp like diligently, LangChain and LangChain OpenAI would be already pre-installed for you. Maybe not OpenAI, but LangChain would be pre-installed for you because our day 3 was strictly on LangChain. So for any of you who are just visiting this bootcamp and are willing to understand about like what exactly is LangChain, you can loop back to our day 3 where an expert speaker and a seasoned professional has explained to you what exactly a LangChain is, and also within a practical example. So once these steps are done, we will just start coding. So rather than coding everything from scratch, what I have done is I have taken, I have created a template code for the same. So whenever you work with, kind of what do you say, frameworks or maybe the modules such as LangChain, or if you ever have experienced the development aspect of machine learning, you will notice that there are functions which you need to constantly use again and again and again, right? So for these type of functions where you don't have to necessarily code everything by hand, rather copy paste from the documentation, right? So this is one of those moments. So I will simply just copy paste it from the template one by one, explaining you each and every line. So firstly, we will copy and paste the inputs, right? So what Azure Chat OpenAI does is that it imports the Azure OpenAI. Since we will be using Azure OpenAI's API key, which will act as an LLM for this example, right? It imports the entire Azure OpenAI wrapper for that and the necessary dependencies for that. So, imports Azure OpenAI's wrapper. Then we have from LangChain memory import conversation buffer memory, right? So imports the buffer memory function, which will help us to initialize the buffer memory for our entire conversation, so it can remain in one simple context. Then we have the conversation chain. So the conversation chain function acts as kind of the building block to bring our conversation to life when using LangChain, right? So acts as a building block LangChain. So now then I will quickly copy the Azure LLM code and I will explain to you what each and every variable does. So Azure LLM equals to Azure Chat OpenAI. In the function we have provided around 5 variables. So the OpenAI API version is needed, the Azure deployment is needed, sorry, the Azure deployment name is needed because on Azure, if you ever create an OpenAI resource, right, you need the deployment name. Azure endpoint is needed, and Azure OpenAI API key is needed, right? So ये भी कट डाल देना, pause ले लिया. So basically, the endpoint acts as an API access point, and the API key acts as a password to kind of authorize the request to that particular endpoint. Anyway, now we will be configuring our conversation buffer memory. Here the example is more of more inclined and not even inclined. It is of summary memory, but buffer memory and summary memory by implementation there is only one difference, which is the change of function name, right? So we will just remove these two variables. So like when we kind of now have buffer memory initialized as per our code, right? So initialize buffer memory, and now if we go further and copy the conversation chain, which will actually start the entire conversation, the conversation chain function will start the entire conversation. If we and bring it and directly copy paste it, then you would understand like what variable does what. So when a conversation is started, it needs a LLM. So LLM is provided here. Secondly, it needs a memory buffer, or not exactly a memory buffer, but a place to store things about the conversation. So we have given memory, and we have verbose too. So it is not related to LangChain. It is just a simple function which logs everything. You can even set it to false. There are no issues at all. Anyway, so now we will just copy paste this. So this is nothing but an interactive loop. You can change it and keep it your way as well. So what exactly this piece of code does is that whenever I write exit, it will end the entire conversation. But apart from that, the conversation will continue and my input will be processed as an input to the LLM, right? So now we will quickly save this and run this program. So it may take a few seconds to start. And now if you look closely, we have type exit to end the conversation, which we can try as well. Conversation ended. So we will just restart the conversation and we will now test that if our memory source is working or not. Hi, I am Rajat. So human has written, hi, I am Rajat. So AI is now giving or providing us with a response. It may take a while depending on where your LLM is currently hosted at. Right. So AI writes, hi Rajat, it's great to meet you. I am an AI here to chat, and the entire sentence. So now if I now ask it, what is my name? As per the concept of buffer memory, it should remember everything word to word, and here it has provided us with a response which is relatively faster than the last response. because in the last response some processing was happening. What was that exact processing? That my name was getting stored in the memory, right? My conversation was getting into the context, but since it is already in context, the LLM quickly responds it with your name is Sajat, you just introduced yourself and I remembered, right? So this is how buffer memory works. So now if I say, hi, I am Rajat, I live in India and I like pancakes. I also like traveling, right? So now here will be a good example of how memory can actually, make your AI agent or LLM more efficient. So I just told the, AI that my name is Rajat and I live in India. I like pancakes and I also like traveling, right? So it has given me a very big prompt. I will not read a single word of it. Rather, I will ask a very vague question. Let us see that if it catches from the initial memory, if it can, give me something, or let's just say if I ask it, like recommend me places to, travel to. If it gives me places from India, right? So then it means that our conversation is being stored in memory and our context is like kind of present, right? So I just asked her that where should I travel in winters? Hopefully it shows me places to visit in winters in India. Okay, so it has shown international destinations as well, but if you look closely towards the response, in India, it has specifically curated a list of locations which are in India. How does the AI know? Or this LLM knows I reside in India. It knows because I inserted that I am from India, right? So my prompt where I wrote that I am from India, AI stored it in its memory, and when I asked which places I can travel to, the first thing it showed me the places which are in India, and you can confirm it as well. Gulmarg in Jammu and Kashmir, Oli in Uttarakhand, right? Goa, Meghalaya, and Shillong and Cherrapunji in Meghalaya as well. So yeah, so this is how memory makes your entire AI agent or LLM more efficient for you as a user, right? So this was an example of buffer memory where everything is stored word to word. Now to demonstrate you an actual difference between buffer memory and summary memory would be a little hard because these both require long amount of conversations, and like this particular session is supposed to be short and simple for any beginner who want to understand the concept of memory and can code it easily. So to test that if our summary memory works as well, we will just insert the same kind of inputs, and if it remembers that I am from India, then yes, the summary memory works as well. So the only difference between the code of buffer memory and the summary memory is that in summary memory, in the concept of summary memory, the the LLM itself is used to summarize the entire conversation, right? So we will simply just replace this entire line with this, where and also we will change the imports as well. You can do it in a different file, no issues at all. I will just do it in the same one. And these four files will be given to you via description as well. Okay. So now to understand you, the LLM which will be used to generate summaries is our same LLM, and it is useful. The return messages variable is useful for logging or chaining. So again, that is also an option. You can just set it to false. No issues at all. Now, if I run this particular code, right, so it should run. So I will just give the same prompts again. So I told the system that hi, I'm Rajat, I reside in India. So I will just initiate a random, a little 10-second conversation with the AI as soon as it responds to me. Okay, so it responded to me, and I will also specify that I live in Delhi, right? So if you see the logging, basically the text in green, you will see that Rajat introduces himself and mentions he resides in India, and then one line as well. So basically, the conversation chain is, and the conversation summary memory is already summarizing the entire conversation, right? And this was something which you would not be able to see when we work with buffer memory. So this is the basic difference. Buffer memory stores everything, and summary memory basically makes summaries of the entire conversation and stores it in chunks, right? So summary memory is kind of more efficient when initiating in long conversations, and buffer memory is kind of more efficient when initiating in short conversations, right? So moving back to our PPT. So what to use, when to use, I guess it is now clear. Choose buffer memory when your conversation is brief and you want to preserve every word. Choose summary memory when like the conversation is open-ended and the interaction is longer. So the conclusion is that memory is one of the most powerful tools for building truly intelligent AI agents. It adds depth, context, and continuity to conversations, whether you use buffer memory for accuracy or summary memory for scalability. Choosing the right approach can make or break your user experience, so choose wisely. Anyway, thankfully, the LangChain framework provides us and makes it very easy for us to work with AI agents or agentic AI as a whole, right? So with this, we come towards the end of day 4 session on memory in agents, buffer, and summary, right? So if you like this session, please let us know in the comment box. And if you have any doubts, we will be live on Discord right after this session for a half an hour or maybe 1 hour, where our mentors will be present there, and you can come and ask your doubts freely. Or if you are kind of busy somewhere, and if you are watching this video maybe on a later time, we will be also enabling a Q&A section on our website, on our Discord as well. So you can come and ask your doubts and questions anytime throughout the bootcamp. So this session was brought to you by Kamla, and yeah, see you in the next one. Thank you so much.